And if it is going to be something that does require mathematics, one of my old department chairs, so awesome. She was one of my favorite people of all time. Julia Hudson. I'll get her in my video here. One of her favorite sayings was "Pay now or pay later." You know, you're gonna go through the struggle now, like that one girl that I had in that first chair in my 7th hour, like 4 years ago. Got a C and struggled for it, and then went to college and took the same class and got an A in college because she went through the process, and then it clicked better in college. Pay now or pay later as well. Go through the struggle now so that you're firmer later. Is another thing about how to approach things. Okay, so I froze the screen. And then I'm going to go back up to that top. So just hold off on letter C for a second if you didn't get it down here, because I do want to get the notes started. And then I don't know if you have to see me in class. I'll probably shut me off here. Sometimes I like you to see the double if you're at home, and I do have a lot of absences today. So horizontal asymptotes, when a graph appears to flatten out to the right. We're going to use our graphing calculator, so get it ready, have it out. To the right and left. That means it is getting closer and closer to a horizontal asymptote. We're going to talk about that. We're going to reiterate finding vertical asymptotes. We actually can have more than this just for rational exponents or rational functions, but let's just for right now say zeros in the denominator is where vertical asymptotes come from. But there's more. And we'll see it today in an example. Not just leave it like that. Horizontal asymptotes. Actually, I'm wrong. I'm talking about horizontal asymptotes. Vertical asymptotes really only happen in rational functions. Sorry about that. Horizontal asymptotes can happen in other functions. We'll see one today. But these rules are for rational functions only. So if the higher power is on the bottom, then y equals 0 is an asymptote. Here's an example of this. Y equals, go ahead and stuff this right next to this. Let's say x plus 1 over x squared minus 2. Let's just make something let's just analyze the powers. Okay, going to do a group response. 5th hour doesn't like talking to me a lot of times, though. So in the numerator, what is the degree? The degree. 3, 2, 1, go. 1, here are your friends. It's 1. Okay, now let's get better on the second one. In the denominator, what's the degree? 3, 2, 1, go. 2. The numerator's degree is smaller than the denominator. I'm not going to overanalyze this. I used to in the past and give reasons why, and it only really connected with 1 or 2 students, and the rest were like, just move on. But there's a reason why, and maybe when we get into chapter 2, I'll explain it. At this point, just memorize it, right? And I just will leave it at that. And then we'll see it when we look at the graphing calculator, and I think that's all okay. The second one, this is like, I guess we'll have an example that like this later, or I'm thinking about some, but I'll just make this pretty straightforward. And I'm trying to make them where they don't factor. Just don't worry about factoring now. Just analyze the numerator and denominator's degree. So look at letter B. If the powers are the same, then an asymptote appears at the coefficients that are, and that's kind of worded poorly, I guess, coefficient number over coefficient denominator, numerator and denominator. So let's analyze this one. What's the degree of the numerator? 3, 2, 1, say it. 2. All right, let's go better. What's the sorry, did I say coefficient? Maybe I did. I meant degree. You're right. Okay, what's the degree of the denominator? 3, 2, 1. 2. So they're equal. So you will see that when this happens, the asymptote horizontally is y equals 2/3. And for the love of dog, I know what I have run into problems, and this should not be a cat problem. Knowing that a horizontal line is y equals a number, right? And that's what we practice when we write these things down. We hammer over and over and over again, y equals a number is a horizontal line. X equals a number is a vertical line. And you write this so many times that it should eventually sink in. And I hope that happens. And then the last one, if you wrote the words down, this would be an example of this one. 4x to the third minus 3, I don't know, I'm just making up crap, over 2x squared plus 1. Degree of the numerator, 3, 2, 1, go. 3, only you. Nice, thank you. The degree of the denominator, 3, 2, 1, what is it? 2. Degree is bigger in the numerator. That means there is no horizontal asymptote. And then we'll hold this off into chapter 2. There is something, though. If you did this in math 3, there's something called a slant asymptote. Does anyone remember that? Did you have that? Don't worry about it. Okay, not something that you have to care about. What you have to care about is locking these in. And then when you look at a graph on a graphing calculator comparing to this, it'll make sense. And that's where you just need to be. So in these next examples, I'm going to do vertical asymptotes, horizontal asymptotes, domain, and then range. And then we'll get that all together, and then we'll move on to easier concepts. This is the biggest. This is the biggest conundrum of the chapter, or section 1, 2. Okay, so let's focus on this first one. And I'm going to add to the directions. I'm not only going to identify asymptotes, I'm also going to do domain and range because they really have a lot to do with it. So we're really going to focus on this one. Let's do the vertical asymptote first. The vertical asymptote comes from the zeros of the denominator, and we will see this when we go to our graphing calculator. This is what I told you. You will factor almost every single week in here through till December. Some weeks you're going to factor like 4 times during the week. And if you can't figure out factoring, this is going to be a rough year. So we got to get it down. And what this is a trinomial in our simple MA format. Watch how this looks. But by the way, good foiler, say it. Good packers, we check our answer at the end. Raise your hand if you know what multiplies a -2 and adds to the -1. Please help me out. Bam. -2 and 1. Cover your nose, by the way. Didn't you hear that guy out in the hallway 37 times? X minus 2 then. X plus 1. He said -2, 1, sorry. Good foiler, say it. I'm not doing it to be annoying. I want to push this glass right here. What's going on with Mr. Samuelis? Students that don't understand why I say that every dang day. What's X times X, everybody? Because if you can't FOIL, then you certainly can't factor. What's X times 1? 1x. What's -2 times X? -2x. Those added together is this. That major innumeracy, not being able to do this, really drives me crazy. What's -2 times 1? -2. How come you're not saying anything? Am I scared? All right. Okay, good. Fear is good. No, I'm just kidding. All right, now, what's the vertical asymptote? X equals 2. So you kind of set that and solve for it. Set it equal to 0 and solve. Or, if I plug in 2 for x, I get a 0 in the denominator. If I plug in -1 for x, I get a 0 in the denominator. All right, let's go to horizontal asymptote. What is the degree of the numerator? 3, 2, 1, go. 1. Only a few people are left talking. What's the degree of the denominator? 3, 2, 1, go. 2. Who's bigger? The bottom. When it's bigger on the bottom, or the numerator is smaller than the denominator in degree, it's an automatic y equals 0. Okay, let's go ahead and graph before we look at domain and range, though. Because the horizontal asymptote, something funky happens with this one. Okay, and I do have to ask you, do you guys all have the, I want to clear, obviously I want to clear because that's not the one we're doing. Do you have a fraction button? When I hit alpha y equals, does this menu come up? Does anyone not have that menu come up? I know I asked this yesterday, just want to make sure. Forever hold your peace then. Do the fraction button, hit that one, so you don't have to worry about parentheses. All right, and then I already forgot. What was the numerator? Sorry. X what? Just X? Is it just X? Oh, my bad. I thought there was more. Over, and then I got it. X squared minus X, correct? Minus 2. Sorry for being so slow here. At least, hey, you can't say I'm doing the notes fast at this point. And then I think we zoomed standard yesterday, but I'll just do it again just to make sure. And there we go. And now you make connections. Okay, look at the graph. And I should have had my screen on. I'm going to the screen up here and denoting x equals -1. Look at that asymptotic behavior. Whew. X equals 2. And there should be recall from last year, because I know I just talked to Mrs. Westberg. Math 3, do you do this? Yes. All right, and so you got to build on stuff. If you forget everything from 3 years ago, then what can I do? How can we move on? And then y equals 0. Boom. Boom. Horizontal. There is an imaginary horizontal line controlling those ends. They're actually called end behavior asymptotes, horizontal asymptotes. But, okay, let's talk about the domain. Obviously, the interruptions in the domain are there. So let's go to the domain and annoyingly write what the domain is. And it is, I will say it is annoying. Domain. It is -infinity to infinity, but I cannot have -1 in the domain, nor can I have 2 in the domain. And this is how you have to write it. Oh, that's what I find tough. Back in algebra 2 days, we were able to say the domain is x not equal to -1 and x is not equal to 2, because that implied it equaled everything else but that. So that's the only way through interval notation you can interrupt that. But now let's go back to the graph and analyze what the range is. This is why you do need to look at the picture, because the y equals 0 implies that 0 is not in the range. But look at the middle. What do you think that coordinate is right there? 0, 0. Is y equals 0 in the range? Yes or no? Yes, it is. It's right here. Y does exist as 0, or it is there. So what's the range? All, anyone? All, anyone? It is all real numbers. So even though there is a horizontal asymptote, the range is still all real numbers because of that middle piece. So then again, I'm telling you, you need a graphing calculator for the range. I don't expect you to know what's happening with that graph without looking at it. I know there's a horizontal asymptote of y equals 0, but I don't know that this middle piece exists, right? So I need to graph it. And that's the point I'm trying to make. All right? So that's why we do this with the horizontal asymptotes. Let's move on. And again, I'll leave you alone today. Again, a professor in college would leave you alone. If you don't want to pay attention to the notes, which I think everyone is, they'll take your money next semester. That is a difference, anyone, of 2 squares. But you got to go in order. It is 4 first, so it's 2 first. 2 and 2. What's 2 times 2, everybody? Good FOILers, good factors. I just did first the FOIL. What's x times -x, everybody? What's x times -x, everybody? -x squared. That's how we get that minus. What happens to the middle term, everybody? Cancels. Okay, so I do, and you got to be careful on this. We'll do this more in chapter 2. There could be some factors that cancel, and then we end up with holes. Does anyone remember holes from rational functions last year? Come on, somebody, you're kind of moving your arm. Did you just move your arm? Yes, you did. It wasn't for that, though? Okay. All right, so when I set this equal to 0, I get x equals 2 and x equals -2. Now we got this special situation. Let's do the asymptotes first, then look at the picture. Okay, class, what's the degree of the numerator? 3, 2, 1, go. 2. What's the degree of the denominator? 3, 2, 1. Equal. When it's equal, they said 2. I was making a point that it's equal. Then it's this coefficient in front of the x squareds. What's that number in front of the x squared? 1. So this is y equals 2 over -1, which is y equals -2. Okay, now it's time to go to the graph. And then let's analyze what happens with the range. And then we got something special here. I kind of go out of order on this, meaning like what we're going to, some of the components that I'm trying to get you to know. All right, short-term memory loss here. What was the numerator again? It was just 2x squared. Sorry about that. I actually did forget. And then over, I got that one, 4 minus x squared. Ooh, I'm thirsty, but I'll wait till at the end of the period. You get next period off. Oh, by the way, I will get your homework in. I know I said if your homework's I'm sorry, it's been a long week. Your homework being put in will definitely affect your grade, hopefully positively if you did all your homework. I can't make a guess. I know our homework's like, I think it's built in as 20% of our grade. Just think about that. You know, that's a big chunk. If you get it, all your homework done, then that grade's going to shoot up. You know, I would say someone that has a 55 in a test, you're probably going to have a 62 after I put the homework in if you have it all. So that's the effect of homework, and that's, I think, fair. You know, but if you don't do your homework, then you're your own worst enemy. That's really the truth. So random thoughts there because I see that pile I got to do. I'm doing that next hour. But look, here we go. You can't see me on the computer, but I'm up at the screen here. X equals -2. See? And x equals 2. See the behavior of the graph? There's definitely an interruption there. Oh no. I definitely have that y equals -2 with these two ends. But why I'm saying oh no is there's a big gap in the range. Huge. Well, let's go to my piece of paper and do the domain. The domain, again, annoyingly, is all real numbers except that 2 and -2. So I got to do to -2, -2 to 2, and then 2 to infinity. Imagine if you had 3 asymptotes, there'd be it'd just be annoying. All right? I used to like the algebra 2 days where you just say, x doesn't equal plus or minus 2. And then we were done. The range, though, I got a problem. I don't understand why students can't handle range. Range is y. You analyze the y-axis. You see that these coordinates exist actually twice. By the way, is this function 1 to 1, yes or no? No, it is a function, though. Vertical line test does pass. These are all functions. But it's not 1, 1. So these y's happen twice. Then this boundary at -2, it approaches, never touches. So -2 is not in the range. It's approaching, never getting there. But then we got this gap, and then it starts up again. By the way, what does that coordinate look like right there? What do you think that is? 0, 0. We're going to prove it. Let's go to our calculator. I'm already there. Let's go to second trace. What do you think I'm going to pick out of this menu to find out what's going on at that part? It looks like a parabola. Parabolas had what when it was at the bottom? What was that called? I'm going to give you a hint. It starts with an M. Minimum. This is a low point. So we're going for a minimum. So this was part of my thing. We'll do this on Tuesday, but I think you should remember this from last year or 2 years ago when you did parabolas. You wanted to find what is that minimum right there. And you may or may not have done this with a calculator. Let's just do it now. Okay? So I hit minimum. Look at what it's looking for. It's looking for a left bound. So I did hit my left arrow a couple times. It doesn't matter how many times. Just make sure you're left of the lowest point. And then right bound. You're helping the calculator focus on an area of where you want to find the minimum points. So you want these arrows pointing at each other, and then it's in between those two lines. If you have an older calculator, you don't get those lines, but you do get the arrows. Guess is useless. Just hit enter again until you see the word minimum. What? This always makes me sad, and I'm going to yell at your science teachers for this. This is scientific notation. -1.6 times 10 to the -6. That's simply -0.0000, I think I did 4 zeros, 1. That's essentially what number? I'm holding it up right now. 0. And then what's that second one essentially? 0. That is 0, 0. Your calculator just has some sort of thing wrong with it that it can't say 0, 0. So we need to understand scientific notation to know that. Therefore, the range is this. And I really hope you're able to figure this out with what I'm going to write here. It was the graph all the way down to the bottom, all the way to the horizontal asymptote. Hopefully I didn't put 2 last hour. No one stopped me. I almost put 2 there instead of -2. Then it skips to 0, and 0 was included because it is and was a range value. So for horizontal asymptotes, they are approached but not quite attained. So that is why I put a parenthesis on that. But 0, comma 0, 0 was a y value. So I put a bracket on that. This is where it gets a little tough, and it does. Let's go to this one. We're not going to the graphing calculator because I can do this with a chart of values. This is not a rational function. This is a exponential. Is that right? 55. We're spending a lot of time on this because I told you this is the hardest part. Chart of values. Makes sense out of this graph over here. Group responses again. Let's try to do a good job on this. I'm going to put this right here. 0. 5 to the 0 power. What is anything to the 0 power? 3, 2, 1, go. Oh no, I heard a 0. That's not right. Let's go again. 3, 2, 1. What is it? 1. Anything to the 0 power is 1. That is why you see 0, comma 1 input. Say it. Output. You're going to do a lot of inputting, outputting next week. We're going to graph by hand so that we understand why we make conjectures about what functions should look like. And then I don't think I should bother you with this. I plug in 1, I get 5. I plug in 2, I get 25. And then I keep plugging, and these numbers start taking off. That's why you see this crazy, like this thing going off forever. By the way, there is not a vertical asymptote here. All right? This does continue to span out and up. It just is very steep. So please understand that. And this always makes me sad. This tells me what students really know when they're coming in. I won't ask you, but if you said -5, I want to jump out that window. All right? Good thing we're on the first floor. 5 to the -1st. Only if you have faith in what you think the answer is, say it. What's 5 to the -1st? 3, 2, 1, go. 1/5. Right? And everyone should know that. And I don't care. I'm going to say it. These are basic math things for a higher level math class. And then -2. Okay, it's not negative. It's 1 over what? 25. So it's 1 over 5 squared, which is 1 over 25. And as I keep plugging these negatives, those numbers keep getting infinitely smaller. So small that it's getting annoying to try to graph this to show how small those y values are. You know what humans do? They say, you know what, this will never equal 0. So they put a horizontal asymptote here to make you understand that that will never get 0. It's a boundary. Because it is annoying to keep doing that chart and showing how small those numbers are and then graph those small numbers. That's what a horizontal asymptote is. It's an idea. Okay, and then there is no vertical asymptote, so I'm just going to cross that off. 5 to what power? Are there limitations on x? Heck no. Most functions, there are not limitations. Most functions, the domain is all real numbers. But you can see from that picture, and I hope the dog that you can, that the range is 0 to infinity, not including 0 because of what I just said. You can't take 5 to a power and get 0 as an answer. It's impossible. You can get really close, but you can't quite get there. So there's a different function that does have a horizontal asymptote that's not rational. And I'm going to go to one more, which I thought we did yesterday, but it is kind of special, and you could misidentify stuff. I had an ambitious thing with this, but I made a decision to do something different. Did I do this one yesterday, or yes or no? For domain? I thought so. I think 4th hour I didn't. So we might think that there's a vertical asymptote here, but we analyzed this yesterday that this graph can only be graphed from 2 to -2, and this does actually go to here. Whoops, that's a little mistake, but that's okay. I'm not going to change it. Because of the numerator. 2 squared is 4. 4 minus 4 is 0. Square root of 0 is 0, and I can have a 0 in the numerator. So 2 comma 0 is a point, and negative 2 comma 0 is a point. So yesterday we did say that the domain for this was negative 2 to 2 because of the numerator. This doesn't even like affect the domain. Sure, x cannot equal 3, but do you see 3 in that list right there? Yes or no? No, so it's already taken care of. That's why we don't see an asymptote there. But what's the range? Now we can do this because of my last question. What do I need to find for this graph? Minimum. He's got it over there. So I am going to go ahead and type this real quick, and then we're going to move on to a different concept. Oh, let's just say clear, and then do the second y equals again. Enter, and then I think it was a writ. Was it 4 minus, no, x squared minus 4 minus x squared? 4 minus x squared. Man, memory today. I'm going to do this one more time. I should just show this video. It's the 7th hour. Then walk around and see if they're taking their notes and be all up in their grill. Sounds like a good idea to end the week. Okay, I already did that. I already had that. But now what I want to do is hit second calculate min. The range is awfully strange. Hey, that rhymed. I'm just going to make sure I'm left of that low point. You can go as far as you want. Watch something interesting here. So look at the x values, 1.36, 1.5, ooh, 1.6 repeating. Watch what happens when I hit the next one. 2.1, where'd the cursor go? It's gone because the domain, look at it, it says there is no y value. And that proves again the domain stops at 2. But anyway, I'm going to go back on the curve. Enter, and then look at my arrows. Guess is stupid, and then there it is. All right, what do I want? The x or the y? This is range. What do I want? The y. Okay, and then that's the lowest point. Negative 0.894. I'll go 3 decimal places just to be special. Okay, so the range is negative 0.89420. And we are going to bracket that because that point was literally on the graph. So that exists as a y value. And then I did prove that 0 is that top because you can plug in 2 and get 0 in the numerator. So that's why those have brackets. Okay, let's move on to some easier stuff, some more vocab. See my ambition there. I was going to do a lot more. I think it's overdone. So, function out of function 1, domain 2, range 3, asymptotes is all in that. 4 is continuity. Now, look at this page of notes. And I'm going to tell you right now, you're going to write 1% of this. I just like to give the book credit that you could read about this and they show you a lot more. You just need to know some terms. Like number 1, that's continuous. Look at that picture. That's it. So draw that picture and say, this is continuous. Why is this continuous? Because I never have to pick up my pen. Most graphs are continuous. Lines are continuous. Parabolas are continuous. Absolute value, which are V's, are continuous. Blah, 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 blah. It has to be sometimes really special cases where you have a discontinuity, which I'm going to show you what those are. And don't worry about this example yet. Gonna have my notes weird. And I'm really cutting off these words because I certainly don't want you to write that. Back in the day, I would give the book credit where credit is due, that they do explain this a lot. This, if you can't see it, I can't zoom in anymore, is called a removable discontinuity. And then here's why I'm going to hammer down what you see here. There's a hole right there. And I really hope that you did do a hole in a graph last year or the year before. But that might have been the components that the teacher threw out. And don't worry about it. It's not a big deal. We'll do it in 2.7. You won't have to be responsible for, you're going to be responsible for having to look at a picture and identify what kind of discontinuity it is. So do think about this, why it's discontinuous. I'm drawing. Oh no, I had to pick up my pen because I can't draw through that hole and then go to the other side and then keep drawing the picture. That's discontinuous because I had to pick up my pen. So holes can happen in a graph, and that's what that is. Why is it called removable? They put it in here, it's because you could, if you just patch that real quick, like a pothole, then it would become continuous. You know, and that's why they call it removable. It's kind of silly. Hey, this one's easy, because think about a game. They used to have games like this. I remember there was a roller coaster game, and then when the roller coaster was disconnected, you had to hit the jump button, right? Anyone ever play a game like that before? These games are too old. You guys probably weren't even born yet. Did you hear the word I just said? This is actually called a jump discontinuity. Because for me, if I was on this graph, if I was going along to get from this part to this part, I'd have to jump and hit the jump button to get to that next part. It's definitely discontinuous because I have to pick up my pen. So that's an easy word, especially if it was multiple choice. And then the last one is what we have had for those rational functions, an infinite discontinuity. And I think they call it that because these graphs by the asymptote go off to infinity or negative infinity. They really do. You know, the way these arrows go, they go off into positive or negative infinity as they approach that asymptote for the y values. So discontinuous, if I have to pick up my pen, but then there's three different types: removable, jump, or infinite. Just three vocab words. Ain't no thing. Chicken wing. Everyone okay so far? You all right? Go back, looking around the room. I know a lot of people did do a lot of hard work and they got that B or C. And I just tell you, man, you're on your way. Just I get worried about what we think about that first test and so on and so forth. I'm just gonna, I'm not gonna define that. I'm working with Math 2 and Math 3 students right now, and they're doing this. So I think I can go right to an example. Boom. And this is, so what was continuity? 4. So this is number 5. Increasing and decreasing. And I think I'm going to end here. All right. Even though I showed you maximum and minimum. I showed you how to find the minimum, right? That was number 6, relative extrema, maximums and minimums. So I could have done that. I think maybe in the homework it does leak into there. Okay, let's look at this picture and go ahead and just mark it real quick and put the coordinates down because it makes a point. But as you're writing this down, come on, what's my hand doing in the yellow here? Is it going up or down? Down, so it's what? And then what's my hand doing now? Increasing. And then what's my hand doing now? It's not hard. Here's what's tricky though. What's tricky is how do you name the interval where it's increasing or decreasing? This is what I hammered down with. I'm doing this with my math tours as sophomores, so that's why I know you've seen this before. And the word decreasing is actually already describing the y. Input, say it. The output's described. The output is decreasing. What's the input that makes that behavior happen? So I'm making a point, and now I'll reveal the answers, that you name the x's that create that behavior. So here for this yellow part, from negative infinity to 1, notice the x coordinate is picked. That's why when you draw this picture, you want to make a note to self. From negative infinity to 1, and it's a parenthesis. The reason is at 1, there's a change of direction. It's neither increasing or decreasing at 1 for x. It's actually constant for a millisecond. You'll find that out in calculus with derivatives and slopes of tangent lines. Then there is a little point of inflection here. Don't worry about that term, but it never changes direction. So from 1 to 5, it's increasing. And those are parentheses, not brackets. And then from 5 to infinity for x, it decreases again. That's why I have to. And I don't know if you really need a union for that. I don't think you really do. I think it's just a comma. I think you've done that before. The biggest thing that students miss, though, is they name the y's, not the x's. You got to name the x's for your intervals. All right, and then I think you can handle this. I just shoved this at my last hour at the end. If I give you an equation, you have to do this. You have to go to the what? Starts with a G and ends with a C. Graphing calculator. You look at the picture and then you try to identify these x coordinates where the graph changes. So this is a weird graph. It goes like this, then this, and then you maybe use the trace feature to find where what these coordinates are, and then you go through the process. I don't think it's that hard. And I do have to change these brackets to parentheses. And notice it's the x's that are named, not the y's. Okay, we'll end that video. There is a tiny assignment again on there. Yes, you got 3 days. I think it's 9 questions. Do 3 tonight, 2 on Saturday, 2 on Sunday, and then where are we at right now? 3, 4, 5, 6, 7. 2 on Monday. There's 9 questions.